Hi everyone, in this video we will be looking at significant figures. We will be learning the 5 different rules to identify the digits which are significant. So, when is a digit significant? Before we begin, I would like you to actually have the worksheet that I've given you in class already, so please watch this video and fill up the worksheet at the same time. So, we are going to be investigating when is a digit significant. Given these numbers 192, 83.761, 3 and 4.5, I want to tell you that 192 is considered 3 significant figures, 83.761 is considered 5 significant figures, and 3 is considered 1 significant figure, and 4.5 is considered 2 significant figures. So looking at these 4 numbers itself, how do you think I identified the number of significant figures? I hope you realize that I actually counted the number of digits found in the number, okay, in order to conclude the number of significant figures. So for instance, with the number 192, I see that I have the digit 1, 9, and 2, and conclude that there are 3 significant figures. Next, when I have the number 83.761, I see that I have the digits 8, 3, 7, 6, and 1. So there are 5 digits in total, therefore I have 5 significant figures. Needless to say, for the number 3 and 4.5, the same seems to apply where I look at the number of digits to conclude the number of significant figure. So at this juncture, we like to ask ourselves, does this mean that the number of significant figures is just simply the number of digits there are in the number? Next, we look at these numbers over here. I have 1.09, that is also a 3 significant figure, and then we have 0.00174, and in this case, it is actually a 3 significant figure, and then I have 0.0500, which is 3 significant figures as well. Notice that with 1.09, 0.00174, and 0.0500, they are actually the introduction of the digit 0 into the number itself. Unlike our first row of numbers, you see that these numbers do not have 0 inside it. But now, when there are zeros inside it, it seems like the way we counted earlier on doesn't seem to apply. Earlier on, we said that the number of digits is the number of significant figures. It seems to apply for the number 1.09. But then, when it comes to 0.00174, I want us to notice that there are actually 1, 2, 3, 4, 5, and 6 digits over here. However, there are only 3 significant figures. Then, when we look at the number 0.0500, notice that there are actually 1, 2, 3, 4, and 5 digits, and yet I call it 3 significant figures only. So what exactly is happening? This means that with the digit 0, it actually determines how we go about counting the number of significant figures. So when we have 0 in between non-zero digits, in this case 1 and 9 are non-zero digits, 0 itself is considered significant. So therefore, I count this as 1, 2, and 3 significant figures. However, in a decimal like this, when I have 0.00174, as long as I have zeros at the beginning, and there are no non-zero digits over here, okay, so that means if there are zeros at the beginning, I do not count these zeros as significant at all. I start counting my first significant figure from this number 1. So my significant figure is counted with 1, 7, and 4. So in this case, 174 counts into a total of 3 significant figures. Lastly, with the number 0.0500, So with what we learned in the earlier two numbers, this is a decimal. The first two zeros in front of 5 will not be considered significant, but the zeros after 5 will be considered significant. So we count our significant figures as 5 as the first one, this 0 here as the second one, and this 0 here as the third one. So there are actually 3 significant figures. How you can think about this is that because we know that 0.0500 is the same as 0.05, and yet I intentionally wrote in this additional 2 zeros at the back. Because we intentionally wrote it in despite knowing that it is actually the same value as 0.05, because we intentionally wrote that, therefore it will be considered as significant. Okay, significant, another idea about significant is that it is important. Because these two zeros here must have been important for us to consider it as significant. So with this idea about decimals and how we see zeros, let's try some examples. Let's look at the number 3.0024, 0.10908, and 0.10. How many significant figures do you think there are? Let me give you a 30-second pause to think about this. You may wish to pause this video for a while to think. Now let's check our answers. So with 3.0024, these zeros here are in between non-zero numbers. Okay, 3 and 2 are non-zero. So therefore, we start counting from this 3 here, and there are 1, 2, 3, 4, and 5 significant figures. Next, in the number 0.10908, it is a decimal number. This started off with 0. We do not count this 0 as significant. We only start counting from this 1 over here. So this is 1 significant figure, 2 significant figures, 3 significant figures, 4 significant figures, and lastly 5 significant figures. Hence our answer would be 5 significant figures. Lastly, looking at the number 0.10, likewise, because this is a decimal, we do not count this 0 as significant. We start counting from this 1 over here. This 0, I intentionally wrote it there already, so I will need to count it as significant as well. So there are 1 and 2 significant figures to this number. I hope you get a better idea about significant figures so far. Next, we look at these next few examples. I'd like you to take a pause over here to think about your answers for these remaining 6 new numbers and write it inside your worksheet. Okay, I hope you are done. Now let's check our answers. So in these numbers over here, 5062, there should be 4 significant figures because we count as 1, 2, 3, and 4 digits that are actually that is in a whole number, so there are 4 significant figures. Next, in this number 0.06032, we start counting at this 6, and there are 1, 2, 3, and 4 significant figures. Next, in the number 6.090, we have to start counting from this 6. There are 1, 2, 3, and 4 significant figures over here. Next, in the number 70.8001, all the zeros are actually found in between non-zero digits, so we have to count the zeros as important. Therefore, we have 7 as the first significant figure, second significant figure over here, third, fourth, fifth, and sixth significant figures. Next, in the number 0.021, this is a decimal. We do not count these zeros as significant. We start counting from this digit 2. So this is our first significant figure, and then the 1 is our second significant figure. And lastly, in this number 41.0320, I will have to count this 0 as significant. Likewise, I need to count this ending 0 as significant as well. Therefore, I will have 1, 2, 3, 4, 5, and 6 significant figures. I hope that you have an idea now about when is it that a digit is significant. In summary, these are the rules that we have covered based on the example earlier. So the first rule is that all non-zero digits are significant. So that means that if you see digits that are 1, 2, 3, all the way to 9, they will always be considered as significant and we will count them in. The second rule and the third rule, as well as the fourth rule, discusses about our zeros itself. So in the second rule, it says that all zeros between non-zero digits are significant. So an example would be over here in this second rule. We see that our zeros are actually all in between non-zero numbers. Okay, therefore we counted this zero as significant. That is our second rule. In our third rule, we are looking at a decimal number only, which says that all zeros before a non-zero digit are actually not significant. So we do not count it in. That is seen in our third row over here, whereby the number actually starts off with a lot of zeros. So regardless of how many zeros there are, okay, we do not count the starting zeros in a decimal as significant. Lastly, in our rule 4, we are looking at a decimal again, which says that all zero after a non-zero digit will always be considered significant. That is seen in our fourth row over here, whereby we are ending off with quite a number of zeros, okay, and that is after a non-zero number, okay, and therefore these zeros are actually considered significant and we will count them into these numbers over here. So this is a summary of the 4 rules that we have in counting significant figures. But this is not all. I want us to notice that in rule number 3 and rule number 4, we are discussing about the zeros found in a decimal. We have not yet discussed about zeros that are found in a whole number itself. So the key question over here is, what if the zeros are at the end of a whole number? If the zeros are in between a whole number, so for example, 5062 in this case, whereby it is a whole number and we have this zero here, we have already covered that this zero will be considered as significant because of our rule number 2, where all zeros between non-zero digits will be considered significant. Typically, in our whole number, we do not start off with a zero. So for example, in my number 5062, I do not go about writing 05062 to represent the value of 5062. Therefore, our concern for whole numbers is that what if the zeros are at the end of a whole number? So let's take a look at some examples. Over here, I have the whole numbers 3,800, 25,000, and 100,000. I have placed some units at the back of these numbers to give us a little bit of context to help us understand why this idea or this discussion is going to be useful. I have already listed down over here that the answers to these respective situations are actually 3 significant figures, 5 and 2 significant figures respectively. So let's first take a look at this first number over here, 3,800 meters. Okay, imagine a question that is asking you to round off, okay, this number 3,796 meters to the nearest 10 meters. So for example, okay, maybe it is not feasible for all of us to be running 3,000 over meters, okay, but let's say, okay, I have already run 3,796 meters. But then when I report it to my PE teacher, my PE teacher tells me, okay, go and round off to a nice number, round it to the nearest 10 meters. Then what should I do? Okay, so earlier on, if we look at rounding of whole numbers, we look for the tens place first, and that is represented by the digit 9. And then in the second step, I look at the digit after that, which is 6. Okay, and understand that because it is a 6, which is more than 5, I will have to round up my digit 9 over here. And when rounding up my digit 9, okay, the next value it will have to be 10. That means that my 7 over here will have to add in one more value to become an 8. So that's why the number 3,796 meters will then be rounded off to 3,800 meters. So because in this particular question, the way that it is rounded off, coincidentally, due to the 9 being rounded up into 10, a 0 has been replaced, or rather, a 0 has been used to replace this 9 over here. This 0 that is being used to replace the 9 is considered important. Therefore, the digits 3, 8, and then 0, these are actually important digits to have when rounding off to the nearest 10 meters, because we were looking up to this placing of the number itself. The additional 0 over here serves as the purpose of place holding, okay, to maintain that this value here of 3,796 still remains similar to 3,800 meters. Okay, so therefore this 0 over here serves the purpose of place holding. Okay, we do not count it as significant at all. Imagine a situation where we have 3,796 meters, and I am going to report this to my favorite PE teacher, who asked me to round it off to 10 meters, to the nearest 10 meters. And then I told him that it is going to be 380. Do you think that makes sense? Because I definitely ran 3,796 meters, and then I reported it as 380. Then I really wasted a lot of effort, didn't I? Okay, so therefore, the 0 over here, the importance of it is to actually hold the place value, okay, instead of counting as a significant figure itself, due to the question asking me to round it off to 10 meters, to the nearest 10 meters. Okay, so let's look at a second example to really understand, okay, what how we go about determining the number of significant figures in a whole number with many zeros at the end. So let's say I have 25,458 kilometers over here. Okay, and the question asked me to round it off to nearest kilometers. Nearest kilometer would be looking at the whole number itself. That means that we are stopping the rounding, okay, up to before the decimal place, which is this 0 over here. Okay, so we examine the digit on the right, which is a 4, which causes my 0 to round down. And by rounding down, it means that I will keep this 0 as it is. I do not do anything at all to it. I do not need to replace 458 with any zeros at all, okay, because they do not hold any significance they do not hold any importance in maintaining place value of the number. Okay, so I can just remove the 0.458 since they are no longer important, and give my answer as 25,000 kilometers when rounded off to nearest kilometer. So because it was rounding off up to this 0 over here, I will count it as first, second, third, fourth, and fifth significant figure. Okay, so there are actually 5 significant figures to this number when rounded off to nearest kilometer. So looking at these two examples, I want you to already have the idea that it is really depending on how the question actually wants you to round off to help us go about counting the number of significant figures. So let's look at the last example. If I am given the number 98,576 gram and I want to round it off to the nearest 10,000 gram, the 10,000 place value is actually at this digit 9 over here. The digit after 9 is actually a 8, which means that my 9 has to be rounded up. And when 9 is rounded up, it becomes a 10. So we see that before this 9, there is actually no digit before it. Okay, so we will have to add a 1, okay, to the no digit before. Okay, so that's why I have this 10 over here. Okay, and then my 8, 5, 7, and 6 has been replaced by this 0, 0, 0, and 0. All these remaining 4 zeros at the back, it serves the purpose of maintaining the place value in this original number. Therefore, in order to count the number of significant figures, I will only be counting this 1 over here and this 0 because that was how I went about rounding off. I was supposed to end my counting at this place value, okay, which is actually the 10,000 place value. In this case, the 10,000 place value is this first 0, so I will only count the 1 and that first 0. I will not count the remaining 4 zeros since their purpose is to maintain place value. Okay, so in conclusion, the fifth rule to significant figure is that the zeros at the end of a whole number may or may not be significant depending on how the number is rounded off. I know that this concept, okay, for the fifth rule can be a little bit difficult to understand. Alright, if you still have any questions, you may check in with me when we meet together again in the next lesson. Alright, otherwise, please do give the questions in the SLS a try. I will definitely cover them, okay, if you have any concerns during the next lesson itself. And this is all for our significant figures. I'll see you again in the next lesson. Bye bye.